5.1 functions. For the learning outcomes for today, sketching the graphical approach of the function. And the second one, find the domain and range of the function for quadratic function. Okay, quadratic function. What is the definition of quadratic function? A quadratic function is a set of the form fx equals to ax squared plus bx plus c, where a cannot be 0. And then the graph of the quadratic function is a parabola and has a maximum point when a less than 0 and a minimum point when a greater than 0. So these are the shape: minimum and maximum. When a less than 0, the graph is like this, is a maximum, which is hk is a maximum point for quadratic function. When a greater than 0, which is the graph is minimum at hk for quadratic function. Okay, for quadratic function fx equal to ax squared for type 1, we have a basic graph for x squared, 2x squared, or 3x squared, or many more, or even half x squared. But normally, sketching a quadratic function, we just want a basic shape, not not accuracy of graph. We just want the shape of the graph. Either is a minimum or maximum only. Okay, for type 2, fx equals to ax squared plus c. This graph has a basic graph, which is y equals to x squared. This one. We have this graph, y equals to x squared. The basic graph, this is a minimum. They have some minimum because a greater than 0. When x squared plus with a constant, meaning plus 3, this means the graph shift up 3 units. When the same graph x squared but with a minus 4, meaning shift down 4 units. So the original graph is x squared, and if we have a plus constant, meaning the graph is shift up, or when minus something is meaning that the graph shift down. Okay, for example, this one, we have 2x squared. 2x squared, the basic graph is at origin 0, 0. But when you minus 5, so the graph already shift down 5 units. Okay, fx equals to x squared minus 3. So this is the original graph. X squared at 0, 0. So at 0, 0. So when we have a greater than 0, this is a smiley graph. And then we have negative 3, meaning this graph is shift 3 units below x-axis at negative 3. Okay, so how to write the domain? The domain, all the set of value of x are defined. So from negative infinity, infinity, or sometimes you can write x is real number, is also accepted. And for the range, okay, for the range below negative 3, there is no graph. But from negative 3 and above, so there is graph exists. So we start negative 3, and above for the range. So this is how to write. Include -3 until infinity, or you can write y greater equal than -3. Okay, let's try another example. Fx equals to -3x squared plus 2. So this graph, we have -3 in front, so a less than 0, which is maximum. That this graph have a maximum. And then the basic shape for this one is x0, y0. This is for 3x squared, -3x squared. And how about plus 2? Plus 2 meaning the graph shift 2 units up from 0, 0. So the same graph, but shift 2 units from 0, 0. So y2 lah. So after that, from this graph, we can write the domain. So all set of x are defined. So this is -infinity, infinity. And the range, okay, so look at the graph. Above 2 and more than 2, there is no graph. But the graph exists from the graph exists from 2 and below. So this is the range 2 and below. So we start from 2 is the highest, so 2 close. This is the smallest one from -infinity. Or we can write y less equal than 2. Okay, let's move to the type 3 for quadratic function. This quadratic function, they have fx equals to ax squared plus bx plus c. The tip to solve this question, we use maximum and minimum point. Normally for this type of question, you will be you will see the question like this. For example, okay, 2x squared minus 4x plus 3. You take out what is a, what is b, what is c. So all this value we sub into the formula h. To find h, we just use -b over 2a. This is the formula to find h. And then for k equals to half h. So you have to find h first in order to find k. Alright, so after that you will find the minimum or maximum point for this quadratic function. Okay, we try this example. Fx equals to 2x squared minus 4x plus 5. Okay, for this question, we take out what is a. A is 2, b is -4, c is 5. And at this time, we know that a is positive, greater than 0. So your graph should be minimum. Okay, so this value, we have to find h. So h, -b over 2a. So just substitute into the formula. So let's check the values. Substitute into this formula. Negative. Our 4 is -4. Okay, -4 over 2. A kita 2. So you get 1. Correct? To find k, so you have to substitute f1, the original function. So find the original function. You've put x1, so you get f1 is 3. So substitute the value, you get 1, 3. So 1, 3, actually, this value 1, 3 is a minimum point. Okay, so sketch the graph. 1, 3 here. So smiley graph. Okay, so you get 1, 3 here. It's a minimum point. 1, 3. And then for the y-intercept, you can get from x0. So you get y what lah. So from here f0 you get 2 times 0 minus 4 times 0 plus 5, you get y5. Okay, so from this graph you can read the domain is negative infinity infinity. All the x are defined, but for the range, look at the graph, we start from 3 close to infinity, or we can write y greater equal than 3. Okay, for this example, fx equals to negative 3x squared plus 6x minus 5. So we see that this is has a maximum value which is a less than 0. Alright, so take out a is negative 3, b is 6, c is negative 5. So all this value we substitute into h formula. H equals to negative b over 2a. So from here substitute b, which is 6, so a negative 3, so you get 1. Alright, so when h is 1, so substitute into the original function f1, so you get negative 2. Is it correct? Negative 2 plus 6, 3, 3 minus 5, negative 2, correct. So after that, we get hk. Hk is 1, negative 2 is maximum point. Okay, so where is 1, negative 2? Okay, 1 is here, negative 2 is below here, so here. Okay, so 1, negative 2, and then this is a maximum, meaning, so the graph should be like this. And then negative 5, when x0, so you get f0, you get negative 5. So the y-intercept is negative 5, so below negative 2. So let's sketch the graph. So this is negative 5. Okay, alright, so how to write the domain? The domain, all the set of x are defined, and then the range, okay, the range, the graph start negative 2 and below, so we write negative infinity, comma, negative 2, close, or y less equal than negative 2. Okay, for the type 4, for the quadratic equation, we call it completing the square form of the vertex form. Okay, fx equals to a times x minus h squared plus k. For this form, you do not need to expand. This function. We're just comparing the value of h and k. Alright, so let's say you have fx equals to 2 x minus 3 squared plus 1, for example. So we can see that a here, a is 2, which is greater than 0. So this is the graph is minimum, all right, at HK. So next you find what is H. H is 3 and K is 1. After that, sketch the graph. Okay, notes given for this completing the square or the vertex form. To find the range of for this graph, you can look at the K and also A to show that this is minimum, this is A less than 0 to show that this is maximum, and the K is the starting range of F, and for HK is maximum or minimum point, and from here we can straight away to find domain and range. Okay, we go to this function fx equals to x plus 5 squared. So this is the vertex form, so we can compare with this vertex form. Okay, from here you see that A is 1, which is greater than 0. And then H you get -5. And K actually is 0. Okay, so K 0. So now this is a minimum point at -5, 0. Minimum. Yeah, this is the graph. And then if you want to find the x-intercept, no, y-intercept at 0, so you get y what? Okay, so K0, you see from here, this is range. Okay, for domain first, we know that all x are defined from -infinity to infinity. The range we start 0 to infinity, start here from infinity. So look at the graph, we start y0 to infinity. Below than y0 there is no graph. Next example, fx equals to -3 x plus 1 squared plus 2. So we write down the vertex form here, fx. We use fx a x minus h squared plus k. So a is -3, which is less than 0. You have a maximum point for this graph. So h is -1, right? K is 2, correct? Alright, so we put -1 and 2, so you have -1 here and 2 here. There is a maximum happen here, -1, 2. And if you want to know this graph for the y-intercept, when x 0, so just substitute here, 0, 1, 1 squared is 1 times -3 plus 1 is -1. So this graph happened here, y-intercept. So let's sketch the graph. Yeah, this one. Alright, so from this graph, what is the domain? Domain is -infinity, infinity. How about the range? So when we look at the graph, we see that the graph start from 2 and below. So we can write -infinity comma 2 close. So here we can see that the starting point for the range. Alright, please try this question for exercise for question A, B, and C.